Ways of treating oil spill. Oil spill refers to the leakage of petroleum from an oil tanker or other vessel. If not treated properly, such spilled petroleum would greatly impact human health and the environment. In some cases, when the possibility of oil polluting coastal regions or marine industries is small, the best method is to leave the oil alone to disperse by natural means. A combination of wind, sun, current, and wave action will rapidly disperse and evaporate most oils. In most cases, however, additional means have to be employed to minimize the potential damage. Since no two oil spills are the same, the key to effectively combating spills is careful selection and proper use of the equipment and materials best suited to the type of oil and the condition at the spill site, including its geographic isolation, weather conditions, body of water, and type of shoreline. Broadly speaking, there are four main methods of response. One type of response to an oil spill is mechanical containment. Mechanical containment, or recovery, is the primary line of defense against oil spills in many countries. It mainly includes a variety of booms, barriers, and skimmers which are used to capture and store the spilled oil until it can be disposed of properly. Spilled oil floats on water initially forms a slick that is a few millimeters thick. The employment of various types of containment equipment is either to surround and isolate this slick or to block the passage of the slick to vulnerable areas, such as at the intake of a desalination plant or fish farm pens or other sensitive locations. Boom types vary from inflatable neoprene tubes to solid but buoyant material. Some are designed to sit flush on tidal flats, while others are applicable to deeper water and have skirts which hang down about a meter below the waterline. Skimmers that are contained within the boom often float across the top of the slick and suck or scoop the oil into storage tanks on nearby vessels or on the shore. However, booms and skimmers are less effective when deployed in high winds and high seas. There are also chemical methods which can be used in conjunction with mechanical means for containing and cleaning up oil spills. They mainly involve the use of dispersants to break up the oil and speed natural biodegradation. Dispersants act by reducing the surface tension and hence stopping oil and water from mixing. Small droplets of oil are then formed, which helps promote rapid dilution of the oil by water movements. The formation of droplets also increases the oil surface area, thus increasing the exposure to natural evaporation and bacterial action. Dispersants are most effective when used within an hour or two of the initial spill. However, they are not appropriate for all oils and all locations. Besides, inappropriate dispersion of oil through the water column. Oil can affect marine organisms like deep water corals and seagrass, and can also cause oil to be temporarily accumulated by subtidal seafood. Therefore, decisions on whether or not to use dispersants to combat an oil spill must be made in each individual case, according to the time since the spill, the weather conditions, the particular environment involved, and the type of oil that has been spilt. A biological method is another means to speed the oil's natural biodegradation apart from the chemical method. Yet unlike dispersants, introduced biological agents to the spill hasten biodegradation in a different way. Most of the components of oil washed up along the shoreline can be broken down by bacteria and other microorganisms into harmless substances such as fatty acids and carbon dioxide. The addition of fertilizing nutrients like nitrogen and phosphorus can stimulate the growth of these microorganisms, thereby speeding up the oil's natural biodegradation process. However, the effectiveness of this technique depends on factors such as whether the ground treated has sand or pebbles, and whether the fertilizer is water-soluble or applied in pellet or liquid form. If the leaked oil has reached seashore, physical methods are often used to clean up shorelines. Natural processes such as evaporation, oxidation, and biodegradation can start the cleanup process, but are generally too slow to provide adequate environmental recovery. Physical methods, such as wiping the sorbent materials, pressure washing, and raking and bulldozing, can be used to assist these natural processes.